I'm Sophia Quee, and I'm here to teach you about the derivatives of inverse functions. Today, we're going to talk about what an inverse function is and the different properties of inverse functions. Then, we're going to talk about how to solve an inverse function without using the formula, because it's important to understand the logic and reasoning behind solving them before just relying on the formula. And finally, we're going to do a proof of the formula and common mistakes. Now, before we can begin solving for the derivative of inverse functions, we must first understand what inverse functions are. Now, Webster's dictionary defines an inverse as something that is the opposite, or the reciprocal of a designated quantity. Now, that is basically what we're doing here in math. So to find the inverse, you just flip the x and y value. So you have, for this equation, it would be x equals 2y plus 4. From there, you can just isolate y using your normal methods. And an interesting thing is when you notice the graph, you can see that the two lines are reflected over y equals x, which is basically one of the properties that defines an inverse. Another one of the properties I already mentioned is that the x and y values are switched, and then the final and important quality they have is that the slopes are the opposite, or the reciprocal. Okay, I think you guys are ready to solve for the derivative of this inverse equation. So, to start, we need to find the x's and y values that match up with our derivative of what we're trying to find. So, if we're trying to find g of x of 1/2, we know that the x's and y's are switched. So, in the inverse, it's 1/2 comma something, but in our original function, it's going to be something comma 1/2. Now, we can solve for this value by plugging in 1/2 as our y value. So then we have 1/2 equals x squared over x plus 1. Now, you can solve this equation just by looking at it. If you solve logically in your head, you can realize that just 1, if you plug in 1 on the top and the bottom, it's going to equal 1/2. This works out really nice for a lot of inverse problems. So then, once you find that x equals 1, you plug it in here and here. And now you have your points. So from there, the next step is to find the derivative of f of x. And we can solve this by taking the quotient rule. So we know that f of x equals 2x times x plus 1 minus x squared times 1 over x plus 1 squared. And then we can simplify this in just one quick easy step by distributing everything. Oh, gotta have the correct notation, that's very important. Okay, now with this simplified, we go in and plug in our values for the f of x. This one's for g of x, this one's for f of x. So we plug in 1 into this equation, and we get 1 plus 2, which is 3, over 1 plus 1 is 2, squared is 4. So you get 3/4. So now we have the derivative of our f of x value, f of x, and we're trying to find the inverse. And if you remember in the last section, I said that you would just have to take the reciprocal if you have the corresponding points. And we do. So now all you have to do is rewrite the answer. G of 1/2 equals 4/3, the reciprocal of our f of x. And that's how you find the derivative of the inverse equation. So here is the equation for finding the derivative of an inverse function. However, it is completely useless if you don't understand where it comes from and how to use it. And you already understand how to solve it without using that equation as seen previously. But if you want to use the formula, this is where the formula comes from. Now, if we start with this formula, you know that pretty much y equals f inverse of x. Now, you know in an inverse, you switch the x and the y values, so that was the next step. Function of y equals x. Then, we take the derivative of both sides because we're trying to find the derivative of the inverse function. And so you do that there, and then you have chain rule, so you do the function of y times the derivative of y equals 1, because derivative of x is 1. And then you can isolate dy dx by dividing the f prime of y to the other side. And then you can plug in y because you know what y is from over here. and you get 1 over f prime of f inverse of x. And this is an equation you can use to solve for values if you're stuck. But make sure not to just rely on this formula and to also use the logic that you just learned. Here are some common mistakes that many people make while solving the derivatives of inverse functions. Now, many people forget to switch the x and y values, or they plug in the wrong value when they're trying to solve for the derivative. If we go back to the one we solved together, if you remember, this is the one that corresponds to the f of x, and this is the one that corresponds to the g of x, but sometimes it's easy to get them confused and plug in the wrong answer, giving you the wrong derivative. Another big mistake is forgetting to take the reciprocal, or getting these mixed up. My biggest issue is getting these two values mixed up and sometimes plugging in the wrong ones. But another common error is forgetting to take the reciprocal at the very end and just forgetting that final step, which is really important. But if you keep those in mind and you use what we've learned in this lesson, I have no doubt in my mind that you will succeed at taking the derivatives of inverse functions. Thank you for listening.